Hey everybody, I have been asked to work out a couple of the graphing of the cotangent tangent problems as a result of I did ask you guys to submit questions on any of the lessons. So I'd like to address them. I have had a request for both number 5 and number 10 on this particular assignment. One thing I want to stress to you guys, tangent is one of those things that I don't want you to worry about amplitude. I don't want you to worry about a vertical shift because it's such a weird function with a strange behavior that those things are just kind of ancillary. I want you to basically find the asymptotes, know the direction of the behavior, and know basically how the behavior for either tangent or cotangent is, and they cross at a midpoint. I'm not even asking you to calculate the midpoint. I just want you to kind of get the period right, the asymptotes right, and the direction of the behavior. So I don't want you to put too much into this. Alright, number 5. Alright, y is equal to 4 cotangent. Okay, so it's cotangent. 2 theta minus pi over 3 minus 2. And by the way, if you guys see me make a mistake by accident, just please gently let me know via Teams, and I will post it and say, oops, I messed up on whatever. Because it's totally possible. Alright, there's our A, there's our B, there's our C, and there's our D. So this is your basically B times theta plus or minus whatever our C value is. Okay, this is really important to help us with the asymptotes. Alright, just for, matter of order, we can say, okay, the absolute value is our A value. I mean, the amplitude is our absolute value. So you can say that's either going to be plus 4, minus 4, and that's going to be away from the midline shift. But I don't want you to worry about this because it's going to show up in the graph anyway, and I'm not that big of a advocate of having to plot every single point. Alright, period. This is kind of important because you got to know how to space your asymptotes. So because it's tangent and cotangent, they have a period of pi divided by b, which in this case is going to be pi over 2. So your asymptotes will be placed pi over 2 units apart. Alright, that's really the only reason for period in tangent and cotangent. Okay, asymptotes. We're going to find the first two asymptotes, which I like to call either the leftmost and the right, the left and the right to start with, or what I call A sub 1 and A sub 2. Okay? In order to do that, you have to take this expression and you have to put it equal to the undefined radian values for cotangent. Alright, for cotangent, you're going to say, okay, 2 theta minus pi over 3 is equal to 0. That's going to be the first undefined location on the unit circle for cotangent. Then you're going to say on the next one, 2 theta minus pi over 3 is equal to pi, because that's our second location where it's undefined. So we are putting asymptotes at the theta locations where the function would be undefined. Alright, so now we're just going to solve for theta. So obviously you add pi over 3, add pi over 3, you have 2 theta equal to 0 plus pi over 3, which is pi over 3, but we still have to take care of this guy. I don't want 2 theta, I want theta. Right? So I'm going to say, oh, and I multiply both sides by 1/2, so that gives me theta is equal to pi over 6. That's my first asymptote. Now guys, I know the answer key is like kind of wonky how it's spreading the asymptotes out. I don't want you to worry about that. I want you, when you graph one for me, I want it to look like what we're doing here. Alright, plus pi over 3. Alright, plus pi over 3. That's 2 theta, gone, is equal to pi plus pi over 3. So you know that's 3 pi over 3, right? This is the same thing. Plus pi over 3, so that's 4 pi over 3. And we still have to get it to theta. So we're going to multiply both sides by 1/2. And that's going to give me theta equal to, this is going to simplify down to 2 pi over 3. Okay, so we just found our first two asymptotes, which is absolutely critical for graphing tangent or cotangent. Those are our barriers, and that's what our graph is going to be centered around, so to speak. Alright, so what else do we need? Well, I'm going to go ahead and just find the vertical shift just for grins and giggles. Okay, so the vertical shift is our D, right? That's our D value. So you know that the vertical shift, not that I'm asking you to graph this, because the overall graph is going to look the same no matter what. But it is going to be at a horizontal line, right? Y equals whatever the d value is. So in this case, it's y equals -2. So the actual x-axis will drop 2 units down, and that becomes our midline. It still doesn't matter in tangent and cotangent because they're very forgiving in how you graph them. All right, now let's go ahead and get on the graph what we have. All right, so let's say we have this. This is my y-axis. This is my x-axis. Okay, let's go ahead and do a sub 1 and a sub 2. So a sub 1 is a vertical line, and I'm not worried about the vertical shift. We can go ahead and mark the vertical shift. It's down 2 units, right? So we can say our vertical shift is down here. It's our new midline, okay? But I'm still going to put the values at the x-axis. So our a sub 1, which was our first asymptote, was at pi over 6. All right, our a sub 2, we calculated on the last page. You can find it. It is spaced apart by the period, all right? But we had to get 2 to get us started. So our asymptote number 2, and by the way, arrowheads go on that. Asymptote number 2 was 2 pi over 3. We just found that on the last page. Those are our beginning asymptotes. All right, now let's find, because I want you to do 3 periods, we need to find a couple more asymptotes. So all you have to do is you have to add a period to get to the next one. So we're going to have a sub 3. A sub 3 is going to be equal to, if you want a calculation, 2 pi over 3, which is this guy, plus the period, which is pi over 2. Okay, that's our period, because asymptotes are 1 period apart. And then you would do the math, and you would find that that would give you 7 pi over 6. So a sub 3 is 7 pi over 6. All right, now let's find a sub 0, because I need to go one back from here. A sub 0 is going to be equal to a sub 1, which is pi over 6, minus our period, right? That's pi over 6. Our period is pi over 2. So pi over 6 minus pi over 2, right, is the same thing as saying pi over 6 minus 3 pi over 6. I just converted pi over 2 to that. So a sub 0, which is our next asymptote, is going to be equal to negative pi over 3, because this is going to give us negative 2 pi over 6, which reduces to negative pi over 3. Okay, so I'm going to be writing on top of that here. I apologize for that. I'll try to do it in red so you can see it. All right, so this is our next asymptote at negative pi over 3. Boom. All right, so all you have to recognize is, first of all, this is a cotangent function. That means it's going to go opposite of tangent. It's going to start at the bottom and head up. This is our cross point now. This is our new midline. So all you have to do is say, okay, my graph has to cross at this midline. Okay? So in between the asymptotes, we want to make sure that our graph crosses there. All right? So I'm going to do this in, I guess, purple. All right? So it's cotangent. So we're going to say, all right, these are my asymptotes. Those are my barriers. So I'm going to come up and cross. The new midline is down 2 because of our vertical shift, and it's going to snake up this way. Now it is cotangent, so it goes opposite of tangent. Just come up, cross, go this way. I'm not interested in the amplitude. I'm not interested in the points in between the asymptote and the midpoint. I'm not interested in that. Okay? So we're just going to come on up and go. So there we have 3 periods of cotangent. All right? So the graph of this particular function, right, is y equals cotangent, for cotangent 2 theta minus pi over 3. Gosh, I'm having a hard time, guys. Pi over 3, close, minus 2. Alright, so for cotangent, parentheses, 2 theta minus pi over 3, close parentheses, minus 2. That's sorry, kind of messy, but you know we started with number 5. So this is number 5 on that particular sheet. Alright, I'll be back with number 10 because that was also something that was asked for. Okay, I got to pause this for now. Now I got to end it because I got to do another video. I'll be back with number 10.